They are one of the world's oldest living organisms, bacteria. Microscopic cells have inhabited our Earth for more than 3.5 billion years. This is the beginning of a fascinating story of nature, of human beings, and of both together. In 1985, the scientist Professor Dr. Erwin A. Galinski made a fascinating discovery in a dried-out riverbed. In the hostile environment of a salt lake, he found living microorganisms. How can these bacteria survive here? This is a question that was finally answered in the laboratory after intensive research. The survival artist from the salt puddle, which now bears the name Ectotheochodospira halochloris, produces a life-preserving substance, ectoin. This complex molecule stabilizes the cell membranes against the high osmotic pressure of the saline lake. Due to the presence of ectoin, the microorganism exists in an environment that will kill other organisms in a very short time. Researchers realized the magnitude of this discovery very quickly. This substance had the ability to protect cells from harmful effects. The aim of further research was now obvious. How can this cell protection mechanism that nature has developed over millions of years be transferred to humans?
Ectoin is actually the survival molecule for the cells. The bacteria produce ectoin to withstand the environmental stress they are living in. On the first hand, our bacteria are living in a very salty environment, and they produce ectoin to balance their osmotic equilibrium, what means the pressure within the cell. In addition, ectoin stabilizes the cell membranes, the biopolymers in the cell, like enzymes, like protein, like DNA, which are crucial to skin's health, and in the case of this bacteria, they're crucial for survival.
The skin of modern man is constantly exposed to a large number of stress factors. Salt, stress, dryness, and UV radiation, but foreign particles are also its natural enemy. All of these factors put a strain on our largest organ, the skin. Nevertheless, we are not completely defenseless against these external factors, such as bacteria and foreign particles, as the skin has an immune system. A network of cells called the Langerhans cells fight at the front line for our immune system.
The Langerhans cells are actually the major part of our skin's immune system. The immune system is responsible for skin protection against intruders. The Langerhans cells build a dense network in the epidermis of the skin, which is kind of a defense wall, a defense shield to block out intruders like molecules of chemicals, like bacteria, like allergens, to damage our skin. They detect those intruders and they destroy them and eliminate them. Under the influence of UV radiation, for instance, the Langerhans cell breaks this network. It's like a fishing net which is broken in the environment of the sea, and fish can escape. There's a hole. Now we have a hole in the network in the skin. Also, Langerhans cells and intruders can really invade our organism, our skin, and cause major damage.
Even light shining through a window is enough to age the skin noticeably. Ectoin can counter this effect effectively. Clinical tests prove this. It protects the Langerhans cells exposed to UV radiation and ensures that they do not withdraw into deeper parts of the skin. Immune protection, cell protection against heat, UV radiation, and loss of moisture.
As well as in nature, ectoin protects the microorganisms, the cells of the microorganism. It also protects the skin cells in cosmetic applications. We are all subjected to environmental stress like dryness, UV radiation, pollutants, and those effects actually cause skin damage. Ectoin builds up a protective wall around the cells, like in the microorganism, and protects the cell actually of this stress. In addition, it works like a water magnet. It keeps the water in the skin, and we all know humans are by more than 90% made of water. We need this for survival, and especially the skin needs the water in between the cells. Ectoin keeps the water in place, and by this really stabilizes skin cells, the membranes, the enzymes, which are crucial to cell survival and cell's health.
Ectoin appears to give the skin almost all-round protection. The idea of using it in the cosmetic industry is therefore obvious. The question is now how to obtain the massive quantities of ectoin required to serve a mass market. The answer? Breeding on a microbiological level.
For producing ectoin, we apply a biotechnological process here in Merck. This is called bacteria milking. It's like milking a cow, where you have to get the milk out of the cow. Now we apply a process to milk our bacteria. We cultivate the natural microorganisms in big tanks, vessels, we call them bioreactors, in a very salty environment. And the bacteria has to defend itself against the salty environment in producing ectoin. Now we change the environment against a non-salty environment, and the bacterium has to get rid of the ectoin by giving it into the water outside the cells. And this is a milking process, like you imagine it getting milk out of a cow. And we have a workup step following up here, several steps, to get the ectoin out of the water into a fine crystalline powder which we can use in cosmetics afterwards.
The story of ectoin is fascinating proof of how it is possible to work symbiotically with nature. Simply a somewhat different story about man and nature.